Hello everyone, today we're going to talk about frames and machine. Previously we learned how to analyze trusses with the method of section and method of joint and find all the internal forces. Now we're going to talk about frame and machine. So the objective of today's lecture is first learn how to draw the free body diagram of a frame or machine and all its members. Second, we're going to determine the forces acting at the joint and support of a frame or machine. So basically, we need to learn about force at the joints and also support. It's very similar to the analysis we've done for the trusses and other beams that we had. Okay, so for today's outline, first we analyze truss and frames, then we solve some example, and then there is a group problem solving that you can go over it with your friends. All right, let's start with just reviewing what we learned about method of section in trusses. So if we have a truss like this, just a review from previous lectures. So what was the first step? Finding reactions, right? So first of all, we need to find what is the reaction. For example, AX, AY, and let's see, this is just BY. So the next step, after we find a reaction, we just have a cut in a place that we cut only three members because we only have three equations. Then we choose which part is easier to analyze. For example, if we have two forces here and there is no force here, it's easier to analyze the left side of the truss. Then draw free body diagram of a truss and see what is the internal force here. We use sum of fx, sum of fy equals 0, or sum of the moment equals 0. Sometimes we use sum of the moment twice, or sometimes we use method of sections combination of method of section and method of joints. That's all we learned from trusses. So on Friday, we have a quiz from trusses with method of section. And if you have any question, you can see me during my virtual office hours. All right, let's see what is the application of frames. Frames are commonly used to support various external load. But what is the difference between frame or machine with trusses that we learn? Okay. Also, there is some example. There is some example about machines like those you can see in the picture. So they are all machines. They are all machines that we're going to analyze. So usually we are interested to see what is the force at joints, for example, at joint C or joint B, and also we are interested in the force in the support or force here or here in the support, or what is the force from our hand to this machine. So we usually wants to find all forces and moment that required to design the machine members because they have both forces and moment. So we need to know what is the force, what is the moment to design the machine. It's an important topic. Let's see what is the definition of frames versus machine. Okay, look at these two pictures. Which one do you think it's frame? Which one is a machine? for sure, you know the right side picture is a machine. The other one is a frame. So actually, both type of a structure at least have one multi-force members. What is multi-force member? If you remember in terraces, either the member were in tension, T stands for tension, or the member were in compression. Okay, so we call these forces two force members. But in machine, we might have members that they are multi-force members. Okay. There is another difference that machine usually they are stationary. They stay somewhere and then the members are moving. Whereas frames, frames are usually stationary, whereas machine usually have moving members. Okay. All right. Let's see how to analyze a frame or machine. So what do you think about analysis of the frame or machine? As usual, you know you need to find reaction. What else you need to find? Sometimes in frames, you have a member that is two force member, like dB in this one. Either it's in tension or in compression, right? So, but the rest of the machine or frame need to be analyzed. But if we have a two force member like dB or in this machine IH, we need to identify those because we can take it apart and analyze it in different way. We already know how to analyze this one. So the first step, as usual, it's finding reactions. Then if we have a two force member, we just take it apart, draw free body diagram, and then solve for this one. Usually when we have something like this, there is a joint. There is a joint and then a support. This member is a two force member. Alright, so the first step is to draw free body diagram and then identify which force is a two force member, like this one. Okay. Then we can start analyzing the part that we want to find the reaction. For example, in this part, we have three unknowns, Cx, Cy, and Fab. There's three unknown, we have three equations we can solve. Once we have the force in Fab, we can apply in the two force member and find the reaction, find the force in two force member, and from there we can tell what is the reaction at A. What is the next step? So again, it's draw free body diagram, identify two force member to simplify the machine or frame, and then apply equilibrium equation. So this is the next step. We're going to apply equilibrium equation. Usually frames and machines are more challenging than trusses because they have multi-force members. That's why it's very important to develop a good strategies to make the problem easier. Like I said, identify all the two force member and then find their reactions and then see what is unknown and start from there. Let's solve an example and see how we can apply the problem-solving strategies we learn for analyzing a frame or machine. Okay, this is the example. It's a frame. So the frame supports an external load and moment. So this is external force and this is external moment. The horizontal and vertical component of the pin reaction at C and the magnitude of reaction at B. Alright, so we want to know what is the reaction at C and also what is the reaction at B. So what is our plan? So our plan is first we need to draw free body diagram and then see if we have two force member. Do you think there is any two force member? Yes, this member is a two force member because it's a pin and it connected to support. So either it's in tension or in compression. Okay, so this is the force FAB. Okay, so this is a two force member. I can take it apart and then do the analysis for the rest of the structures. How many reactions I have at C? It's a hinge, so it has two reactions, Cx and Cy. And I can replace these two force members with one force FAB. All right, so now it's easy to find the reaction Cx, Cy, and Fb. So we're looking for Cx, Cy, and Fab. Okay, I have three unknown and I have three equations. It's easy to solve. So at this point, stop the video, draw free body diagram for the frame CB, and then take apart two force member AB, and then write the equation. You need to get the moment about some point that is easier, or use sum of fx, sum of fy, and then come back and check the answer and see how I solve the problem. All right, here is the free body diagram for this frame. So we have two reaction at C, and we have one force because of AB, which is two force member. Now, which point is the easiest point to get the moment to solve for one of these three unknowns? Yes, correct. If you get the moment about C, these two cannot make any moment. The only unknown is FAB, and you can solve for FAB. Okay, just think about it and then write the equation for sum of the moment about C and solve for FAB. All right, let's see what's the equation. The equation is sum of the moment about C, and I assume counterclockwise moment is positive. What I have is FAB, sine and cosine, both components of FAB make moment, like FAB x component and FAC y component. Both of them can make moment. So what is the direction of the moment? For FAB, both of them make clockwise moment about C. So if they make clockwise moment, it means the direction for the moment is negative because it's clockwise moment. So its x component multiply, this is the x component of FAB, x multiply the distance. What is the distance? Is 1 meter. So for this one, this is the distance, right? How about the y component? Y component again make clockwise movement, right? So it's negative. What's the distance? The distance is 3 meter. So it's from C to B, which is the 3 meter. What else we have? We have a concentrated moment, which is 800 here. This is concentrated moment. What is the sign? It's counterclockwise, so it's positive. So counterclockwise moment, which is positive. What else we have? We have external load, right? We have one external load here, which is 400 Newton. So this one multiply the distance, which is 2 meter, and because it makes counterclockwise moment, it's positive. Solving for FAB, we have the force in FAB. Now the problem is easier because we know what is FAB. The next step is writing sum of Fx, sum of Fy to find Cx, Cy. So I stop the video and then solve for Cx and Cy from sum of Fx and sum of Fy equals 0. All right. Now, if I recall from the previous part, FAB is 8843 Newton. So I have this one, just I need to write sum of Fx equals 0, sum of Fy equals 0. For Fx direction, the only things I have is Fx and x component of FAB, so I can find Cx. For Fy, it's only Cy, 400 Newton, and y component of FAB. Then I solve for reaction. So that's all for analyzing a frame with this method. So first of all, find two force member, which is this one, then analyze the remaining part of the frame with finding reaction or force in two force member with three equation of equilibrium. All right, let's solve another example and see how we can apply what we learned. The next problem is more complex. So let's see what is the next problem. So the wall crane supports an external load of 700. The force in the cable at which motor W and the horizontal and vertical component of the pin reaction at B, C, and A. Anytime we have a pulley like this that is connected to beam, they have reaction. They are similar to the hinge, so they have two reaction. So basically, we need to find the reaction Cx, Cy, Ex, Ey, and also the force in a cable. So we want to know what is the force in this cable. So what is our plan? First, we need to draw a free body diagram for all the frame members and pulleys. Whenever we have a pulleys, we need to analyze each pulley separately. For example, we analyze this pulley first. So this is 700. There is two cables here. So each cable has 350 pound force. And then we go up and calculate all the force in pulleys. Then apply equation of equilibrium and solve for uh, this this machine. Okay, is there any two force member in this machine? Yes, there is one two force member. Look at this one. It's connected with a pin and there is a support here. So this one for sure is in its intention and its two force member. Alright, let's draw free body diagram for a pulley. So first of all, we need to find the force in a cable and then we start from there. Alright, let's start with these pulleys. So this is a 700 here. So half of this 700 is for this one, half of that for this one. So this is all, it's 350 pounds. Then this cable goes all the way to here. So whatever the force is in this part of the pulley, it's similar, it's the same in the other part. So it's 350. Let's go to the next pulley. So it has the same cable, same force. The only thing that is different is this cable has the angle of 30 degree. Alright. So the force is the same. So here is 350. If you look at this cable, this is 350, this is 350. It's the same cable, 350, 350, and 350. So we have all the forces in the cables, and the only thing that we need now is to find the reaction at each pulley, which is Cx, Cy, and Bx, By. So let's go ahead and find the reaction. So again, when we want to find a reaction in a pulley, we need to analyze each pulley and write sum of Fx, sum of Fy equals 0. So in each pulley, if you write sum of Fx equals 0 and sum of Fy equals 0, you can find, for example, Cx and Cy. Similarly, for the next one, you can write sum of Fx equals 0, sum of Fy equals 0, and find Bx and By. Stop the video, go ahead and find the reaction at each pulley. All right, let's see what we get from each pulley. So in the first pulley, the only thing that there is no reaction because it's not connected to the beam. So because it's not connected, there is no reaction at E. The only thing that if we write equilibrium equation is force in the cable. How about the next one? In the next pulley, if you wrote sum of Fx equals 0, sum of Fy equals 0, you already found the Cx and Cy. So Cx and Cy are the same as forces in each cable. Similarly, you're doing the same thing for the third pulley or pulley B, and then you can find Bx, By. The only thing that is different here, this one has an angle, so it has X component and Y component. So make sure you consider this one and this one for the blue force with angle. So here is writing sum of Fx, sum of Fy equals 0. So it's Bx 350, which is this one. All the force in the x direction is Bx 350 and the x component of 350 pound, sine 30. Similarly, for Fy, you can write the equation and find Vy. All right, at this moment, we have all the pulleys reactions. What is the next step? We're going to draw free body diagram for the machine. Okay, here is the reaction, here is the force, and here is the reaction at pulley, and here is the tension into force member, and here is support reaction at point A. What is the next step? The next step is using equilibrium equation. So we have three equations: sum of fx equals 0, sum of fy equals 0, and sum of the moment equals 0. About any point that may be at this problem, point A is the best one because we can get rid of ax, ay, and solve for tb. So stop the video and find force TBD with getting moment about point A. Then you can use sum of fx, sum of fy to find the support reaction at ax and ay. Don't forget the reason that we put one force here is this force is two force member. It's in tension. So it's FBD. Once we have this FBD from here, we can find the reaction at point D. But for now, let's solve for these forces. All right, let's check the answer and see what we get. If we get the moment about A, what forces make moment? AX and AY cannot make moment. There is two component for this one. It's TBD Y component and TBD X component. The X component cannot make moment. The only component that can make a moment is this one, and this one, the highlighted one. The rest of the forces, they're passing through point A, so they cannot make any moment. So this is the Y component multiplied the distance, which is 4 meters. It makes a counterclockwise moment, so that the sign is positive. This one, 303.1, it makes clockwise moment, so it's negative, and the distance is 4 meters again, 4 feet again, and then 700 make counterclockwise moment, it's negative, and the distance is 8 feet. From here, you can solve for TBD. Once you have TBD, which is 2,409 pounds, you can solve for sum of fx, sum of fy equals 0 to find ax and ay. Go ahead and find ax and ay. All right. From sum of fx, what is the forces in the x direction? It's ax, x component of TBD, the reaction in pulley B, and this reaction at pulley C. If you write all these forces with assumption of this direction is positive, you can get AX. Similarly, you can solve for Fy, and you have AY, Y component of TBD, and 303.11 pound. You can find AY. What is the next step? Okay, the first part of the problem asked for reaction at A and force in BD. What is the next one? We still need to find the reaction at D. So the next step is to find reaction dx and dy. What we need to do is just draw a free body diagram for this two force members. So it's like this. There is dx, dy, and here you know the force ft, fbd, and then you can find these two. Stop the video and find dx, dy from sum of fx, sum of fy equals 0. So don't forget that this force has two components, FBD y and FBD x. So you have only two forces. Even without solving the problem, you know dx should be equals to negative FBD, or for the other one, dy is equals to FBD y. All right, let's see the solution. So from writing sum of fx, sum of fy equals 0, you can find dx, dy. Make sure you solve all the sample problem in your textbook, and also the homework will be posted on Canvas soon. If you have any question, just come and meet in my virtual office hour. Don't forget, we have online quiz on Friday from trusses with the method of joint. All right, let's call it a day and enjoy the rest of the day.